Hey, hey!
Ho ho!
All right. So today's lecture, section 2.4a, it's called the chain rule. It's another shortcut to taking derivatives. So here is the formula for the chain rule, but it's really easier probably to memorize it through words. So to take the derivative with respect to x of f of g of x, that means there's a function within a function. It's f prime of g of x times g prime of x. So think of it as the derivative of the outer function, okay? The outer function is f of g of x. So in green, that's the outer. And then the inner function would just be g of x. So you take the derivative of the outer function, which is f prime of g of x, times the derivative of the inner function, g prime of x. Okay, but it's probably easier to learn if you just learn this sentence. Take the derivative of the outer function and multiply it by the derivative of the inner function. Now, I'm going to give a nickname to the inner function so I'm not always constantly saying those four syllables. And I did get this from another teacher. The inner function we are going to call the blop. All right, inner function is the blop. That way I can say by the derivative of the blop instead of inner function again and again and again. Okay, let's do an example. So find f prime of x if f of x is equal to 3x squared plus 1 all squared. So instead of doing this by the chain rule, I want to show you what it's like if we use the product rule. So if we were going to use the product rule, we would just write it out twice. 3x squared plus 1 times 3x squared plus 1. Now we could just FOIL that out and then use the power rule, but let's use the product rule. And so f prime of x is going to be the first 3x squared plus 1 times the derivative of the second, that's just going to be 6x, plus the second 3x squared plus 1 times the derivative of the first, which is also 6x. Okay, so you could basically, this is 3x squared plus 1 times 6x times 2, because there are two of them, right? So that's 2 times 3x squared plus 1 times 6x. Since you're adding the same thing together, we can just multiply by 2. And what you can see here is that you have the exponent. That 2 out front is the exponent, this exponent right here. You have the outer function or we'll just call it the function, but I guess it's really, and then you have the derivative of the inner function. All right, so I guess this 3x squared plus 1 would be the inner function. So the derivative of the inner function is 6x. So using the chain rule on this, we can get to this answer here much faster. So what you do is kind of do it like the power rule. Bring that 2 out front. So it's 2 times 3x squared plus 1. And then we're going to subtract 1 from that function. So it's to the first power. I'm writing it this time for illustrative purposes. And then times the derivative of the blop, the inner function, so times 6x. And you're all done here. So the blop is this right here. So again, pretend all this was just in the past, you know, it might be just 3x squared, but you bring the 2 out front, subtract 1 from the exponent, and then multiply by the derivative of the inner function, heretofore known as the blop, and you're done. So you did all of that so quickly. It's amazing that mathematicians over the past couple hundred years have come up with all these shortcuts. All right, let's keep doing more examples. All right, I'm going to leave the definition up here. I hope I have room to work all these. If not, I'll have to erase that. So our next example is, let's say f of x is equal to 3x squared plus 1. I'm going to go with that same inner function, but to the 200th power. We want to find f prime of x. Now, using the product rule, or the power rule, this would basically be impossible. You'd have to write that out 200 times and multiply it all. Just horrible. But using the chain rule, it's super easy. We're going to bring that 200 out front times the derivative, or times the inner function, 3x squared plus 1. Subtract 1, so it's to the 199th power. And then multiply that by the derivative of the blop, the inner function, which is just 6x. And really, that's it. I do expect you to clean it up a little bit, so let's multiply the 200 times the 6x. So that'd be 1200x times 3x squared plus 1 to the 199th power. Now, one error that I've had students make a lot of times is they forget this exponent. So they would just do 200 times 3x squared plus 1 and just leave that exponent off. Well, you can't do that. That's a pretty major error. Okay, I can fit another one in here. So let's say we have f of x is equal to 3x cubed plus 6x squared minus 5x to the 9th power. So what is f prime of x? Why don't you pause the video and you try this real quick? All right. Okay, hopefully you've tried it. So this is going to be, bring that 9 out front times 3x cubed plus 6x squared minus 5x to the 8th power, and then multiply that by the derivative of the blop, this inner function. Well, that's going to be times 9x squared plus 12x minus 5. So 9x squared, 3 times 3, 9. X squared, 2 times 6, 12x minus 5. And that's really all you have to do. That's the answer. There's no way to easily simplify that anymore. So we just go with that. But what a time saver. Okay, let's do one with a fractional exponent. Let's say we have f of x is equal to 6x to the fourth minus 2x squared plus 3 to the 1/3 power. So f prime of x, bring that 1/3 out front, so 1/3 times 6x to the fourth minus 2x squared plus 3. Now we have to subtract 1 from 1/3, so 1/3 minus 3/3, that'd be negative 2/3. But don't forget to multiply. Another major error my students have made over the past. Forget to multiply by the derivative of the BLOP. So that inner function, 6 times 4 would be 24 x cubed minus 4x. Now I do expect you to put the negative exponent downstairs, all right? So on top we've got 24x cubed minus 4x, and on bottom we would have a 3 times 6x to the fourth minus 2x squared plus 3 to the positive 2/3 power. All right, it looks nasty, but that really wasn't very hard, was it? Okay, let's work a couple where we have to combine computational techniques. So this time I'm going to need a little more space. So 2 more examples and we'll be done. So let's take the derivative, and we have f of x is equal to 2x plus 1 to the 4th power times x cubed minus 1. So here we have a chain rule with this function, that 2x plus 1 to the 4th. We'll have to use the chain rule there, but we also have a product rule. So first we have to do a product rule because we have 2 functions multiplied, and then within that product rule we'll have a chain rule. So f prime of x is the first 2x plus 1 to the fourth times the derivative of the second, that'd be 3x squared, plus the second, x cubed minus 1, times the derivative of the first. And this is where we're going to have a chain rule. So times 4 times 2x plus 1 cubed, and then times the derivative of the BLOP here, which would be 2. So let's clean that up a little bit. And this little section, if you want to squeeze this in above, I'm so sorry. I'll just go ahead and this little subsection, I do have a name for it. Maybe you can put it in the margin. It's combining computational techniques. Okay, so we're going to clean this up. I usually like to bring the non-parenthesis term out front. So 3x squared times 2x plus 1 to the fourth. And then 4 times 2, so that'd be plus 8 times x cubed minus 1 times 2x plus 1 all cubed. So that's really the best way to write that. Okay, the last one I'm going to do, I'm going to need more of the board. All right, so pause the video if you need to, and here we go. So our last one is we have f of x is equal to, so we're going to have a quotient rule involved here, 2x plus 1 all cubed times 3x squared over x squared plus 1 squared. So here we've got a quotient rule. And then the numerator gives us a product rule. And when we take the derivative of both the numerator and denominator, because you have a function cubed and a function squared, you will have to also be doing a chain rule. So start at the far left of your paper, because this one's going to be quite wide. Okay, the quotient rule is the bottom, x squared plus 1 all squared, times the derivative of the top. So I'm going to put all this in brackets. So it's the first, this is product rule here. The top would be a product rule. 2x plus 1 all cubed times the derivative of the second, 6x, plus the second, 3x squared, times the derivative of the first. Well, that'd be times 3 times 2x plus 1 squared. I'm right up here. 3 times 2x plus 1 squared times 2. Okay, so the bottom, the derivative of the top, first times the derivative of the second, plus the second times the derivative of the first, minus, oh man, I'm not going to be able to get all this on here. I wrote too big. Okay, the bottom times the derivative of the top, minus the top, that's going to be 2x plus 1 cubed times 3x squared times the derivative of the bottom. So times 2 times x squared plus 1 to the first power, which you don't have to write, times 2x. So we can't forget the 2x there. So that's what I needed to, hopefully if you had a little extra room, you could put that all over the bottom square. So that's x squared plus 1 squared squared. So that would be to the fourth power. All right, the bottom times the derivative of the top. I'm going to write this out. Minus the top times derivative of the bottom all over the bottom squared. Okay? So that's to the first power. That's the derivative, 2 times x squared plus 1 to the first power times 2x. All right, on my notes, I got it all on one, but I just wrote too big. Okay, so first of all, there's none on your homework this hard. I just wanted to give you one that was just a real nasty one so that you would think the homework was easy. But the homework is page 130, 7 through 29 odd. And I'm going to look over these real quick. So let's go over them real quick to see if there's anything super out of the ordinary here. So 7 looks okay, 9 looks okay, 11, 13, if there's a square root, what power do you want to write that to? All right, that's to the 1/2 power. 15 is to what power? That'd be 1/3, right? And then you've got the square root, so that's 1/2 power again. All right, I think it's going to be, you're going to want to rewrite, instead of use quotient rule, what could we write 1 over x minus 2? That's x minus 2 to what power? All right, it's the minus 1 power. That's the same as x minus 2 to the minus 1. All right, 21, you know, you can square the top and square the bottom. okay, and write those separately as squared, and then rewrite it. What would be the square root of x plus 2? How could you rewrite that? That would be to the x plus 2 to the negative 1/2 power, right? On number 25, there you've got a product rule and a chain rule. 27, same thing, but you're going to have to rewrite that second term. And then 29, rewrite the bottom to a fractional exponent, but you will have a quotient rule with that one. So give it a try. And all of the answers are in the back of the book. So I want you to, if you get it wrong, on the first try, try again before you watch the video. Okay, so try it again. I don't think it's a good practice to just go straight to the solutions video if you miss it, since the answers are all in the back of the book. So give it a second try. That part's really important. Okay, that's it for this video, and I'll talk to you on the solutions video.